Welcome to 3SP-103 Platform module. In this module, we'll introduce the common platform elements and functions across 3 series platform. The functions in these modules are common to all or shared at least by 2 types of 3 series relays. There are 4 sections in this module: protections, controls, inputs and outputs, monitoring. In the protections section, we'll introduce these functions: phase IOC, phase TOC, phase under voltage, phase over voltage, under frequency, over frequency, directional power. Phase IOC is available for 350 and 345 relays. They share most of the common settings except 350 has directional and 345 has CT input and trip winding 1 and 2 breaker settings. Now we're going to use 350 as example and do a setting demonstration. So first, we're going to enable the setting function to be trip. Then we're going to set up the pickup level to be 2 times CT. When we set up the 2 times CT, we have to know that the CT primary is 300 amps, which means we need 6 amps to operate phase IOC. And in the delay setting, we just set 3 seconds as demonstration. For the directional, we're going to set this to disabled. And in the output relay, we can choose relay 3 to operate together with the trip relay. And in the block, we're going to choose contact input 1 to block this function. When the function is blocked, it's like this function being disabled. One picture worth 1,000 words. Let's take a look at the simplified logic diagram of phase IOC and see how they are working internally. When function is set to trip, if no block inputs asserted, then it will pass the AND gate. When phase A input current increased to the pickup level, phase IOC pickup operand will turn on target message, LED, event and transient recorder. After 3 seconds time delay, phase IOC operate operand will turn on target message, event, and transient recorder. Trip LED, relay, and auxiliary relay 3 will turn on too. When block input 1 is asserted, then pickup and operate operand will all drop out. Trip LED stays on until reset button is pressed. That will be covered in the logic diagram of output relay. In the real phase IOC logic diagram, there are more blocking inputs like directional, and there are more current inputs from phase B and C. Phase TOC is the only common element shared by all 3 types of relays. There are some differences. In 350 feeder relays, there's a setting for direction. In 345, we have the settings for CT input and relay 1-2 trip for winding 1-2 breakers. 339 has the common settings for both 350 and 345. These common settings are the function, pickup, curve, time delay multiplier, reset, direction, relays, block 1, 2, 3. If we compare the setting of the IOC with TOC, we can see that time delay is replaced with 3 new settings: curve, multiplier, and reset. The curve selection can select desired TOC inverse curve shape. There are 12 inverse curves for ANSI, IEC, and IAC. And 350 has the settings for the 2 flex curve A and B. There's also 1 user curve setting. The multiplier allows user to shift the selected base curve in the vertical time direction. There are 2 methods of the resetting operation available: instantaneous and linear, intended for coordination with solid state or electromechanical relays. In the example here, we're going to set phase TOC of 350 relay function to trip and pick up level 1 times CT and inverse curve to be extremely inverse, and multiplier set to 2 and reset to instantaneous. Now let's look at the logic diagram of phase TOC. It's almost identical with phase IOC, except the time delay is a calculated value. In our example, when curve is set to extremely inverse, 2 times of pickup current is applied. The trip time will be 3.5 seconds. User curve. Relay provide a selection of user-definable curve shapes used by the time over current protection. The user curve is programmed by selecting the proper parameters in the formula. A, P, Q, B, K are the selected curve parameters. D is a time dial multiplier. V is a ratio between the measured current and pickup setting. Other manufacturers' relay curve can be easily created in user curve. For example, SEL US U2 curve can be easily generated by using these parameters: A 5.95, B 0.18, P 2, Q 1, and K 0. In this way, we can generate SEL curve in the 350 relay. If none of the standard curve and user curve are appropriate, a custom flex curve can be created by entering the trip time at 8 different time values. This curve can be exported into a CSV file and be recorded in the future. Phase under voltage is available for 350 and 339. There are 4 selections in the function. We're going to set this to trip. For the pickup, we're going to set this to 90% of the nominal VT. And time delay can be set to inverse time or definite time. Inverse time can be calculated by using the equation. And we're using inverse time here. And time delay, we're going to use 2 seconds delay when applied voltage is 80% of the VT, then the theoretical trip time will be 18 seconds. For the phases setting, this is the select required phase for the element to operate. We're going to choose any two here. And this way we can avoid single phase VT fuse failure. The minimum operating voltage is a supervision voltage level, and we're going to set this to 0.1 for the VT. When the voltage is below this level, phase under voltage function will be inhibited. In the logic diagram of phase under voltage, the common settings are the same as phase ILC. There are 3 special areas for phase under voltage elements. Firstly, the input signal depends on the VT connection. When VT is set to Y, phase to neutral voltage VAN, BN, CN are used. If VT is in delta connection, phase-to-phase voltage VAB, BC, CA are used. Secondly, there is a minimum voltage supervision level for input voltage. Lastly, the phase inputs are combination. Phase over voltage is also available for 350 and 339. There are 2 settings difference with the phase under voltage. First, there is no inverse curve, it's only definite time setting. Second, there is no minimum supervision voltage. And in example here, we're going to set function to trip and the pickup to be 10% higher than the nominal, delay to 2 seconds, and for the phase to operate to any one phase. The logic diagram of phase over voltage is a simplified one of phase under voltage. Be careful the input voltage in the pickup block. When VT is in delta connection, phase-to-phase voltage should be used to compare with pickup level. 350 and 339 are both equipped with under voltage. The pickup level is usually set to a frequency level considered dangerous for the stability of the system. And for a 60 Hz system, we're going to set 50 Hz as the pickup. In the delay, we're going to use 2 seconds, and minimum voltage supervision works the same way as phase under voltage. We're using 70% here and enable the function to trip. In the logic diagram, we can see the voltage channel phase A is used for frequency measurement. Then compare with the pickup level. Like under frequency, over frequency is also equipped for 350 and 339. In example here, we set the function to trip and pickup to be 60.5 Hz for the nominal frequency of 60 Hz and delay time to be 2 seconds. Over frequency logic diagram is almost identical with under frequency element. One difference is that the minimum supervision voltage level is fixed at 30% of VT, while in under frequency it is adjustable. Directional power is available for 350 and 339 relays. It is response to 3-phase directional power and is designed for reverse power and low forward power application for synchronous machines. The element has adjustable characteristic angle and minimum operating power. The element responds to the following condition. P and Q are active and reactive powers. Angle theta is the element characteristic angles. SMIN is the minimum operating power. For example, the active overpower characteristic is achieved by setting RCA to 0 degree. Reactive overpower by setting RCA to 90 degrees. Active underpower by setting RCA to 180 degrees. And reactive underpower by setting RCA to 270 degrees. In the logic diagram, the operation condition is a calculation of real reactive power with a relay characteristic angle. In the control section, we are going to introduce these functions: change setpoint group, logic elements, breaker control, breaker fail, CT failure, VT fuse failure. Virtual input command is also under the control. We already introduced it when talking the virtual input setups. 350 has two identical setting groups for all protection elements. Group 1 is the default setting group. Switching to Group 2 is available automatically by an contact input or virtual input, remote input, or the logic input. When switching setting group is not wanted, then it can be blocked by the setting of the block group change by any logic input. Logic element from firmware version 2.2 allows user to choose 8 for trigger and 4 for blocking, and the logic gate can be chosen from 6 types of logic gates. In the previous versions, the trigger and block are fixed only to 3, and the logic gate can only choose between OR and AND gate. One application for this logic gate is to prolong the time of virtual input pulse in self-reset mode. In example here, we can assign the trigger source to be the virtual input. And then we can set the timer, dropout timer, to be 100 milliseconds. So this way we can make this virtual input pulse time extended to 100 milliseconds long. Breaker control is available for 350 and 339 relays. In order to use breaker control, we need first configure the breaker under system setup, and in this example we used contact input 1, 2, 3 for the breaker 52A, B, and breaker connected. So now we can use a RTT test set to check the contact input status. So we can open the contact input status and use RTT, turn on the switch 1 and 3 to simulate a breaker closed. First, we check the status of 1 and 3 closed. Then we can check the breaker status from the front panel by using HMI Display. And we can see this breaker is closed. Now, this breaker is local mode is set to on. I'm going to use the front panel to do a breaker open command. And in order to check the output relay status, I'll open the output relay status, and then from the menu, we can select the command, which is under actual values, command, and go to select open, press enter, then use the value key to select open to yes, and then press enter. And now we see this status turned on momentarily, so that means a trip command is sent out from the output relay. Now to simulate a breaker is open, we use the RTT switch to simulate the breaker status is open. Next command we can try is to use the breaker close. So go to the close, press enter, change the command from no to yes, and press enter key. And now we see this close command turned on momentarily, and then we can use the RTT to simulate the breaker is closed. So by setting the local mode on, we can use the front panel keypad. If we set this to off, that means we can use the remote open and close to do the same thing for the breaker control open and close. Breaker fail function is available for all three types of relays. Under function, we can set to alarm or latched alarm. This function monitors the phase current after trip command from protection element is initiated. If any of the phase current is above the set current level after the breaker fail delay time expires, a breaker fail will be declared and will operate the selected output relay. The breaker failure scheme provides also an external input to initiate the breaker failure. From the logic diagram, we can see that time delay 1 is after trip or external initiation. Delay 2 is a total delay for the trigger and current level. CT failure function is available for 350 and 339. Logic detects the presence of zero sequence current at the supervised source without the presence of zero sequence voltage or ground current. VT needs grounded Y connection or 5-limb construction to refer zero sequence voltage for this application. From logic diagram, the trigger of CT fail is initially from computed neutral current, but can be blocked by neutral voltage or ground current, because these two parameters won't be present during the real fault. VT fuse is available for 350 and 339 relays. It has only one setting, is to set this function to trip or alarm. But the logic behind this is not that simple. The measured voltages from the installed phase VTs are monitored and compared against user programmable levels. If one or two of the three voltages drops to less than 70% of nominal, and at the same time any of the three voltages is greater than 85%, either an alarm or a trip will occur after 1 second delay. In this section, we'll introduce these inputs and outputs of 3-series relay: contact inputs, virtual inputs, output relays. 3-series is equipped with 10 contact inputs. The first two are named for the breaker status 52A and 52B, and the rest can be used for the circuit breaker control, external trip, blocking of the protection element, etc. All the contact inputs are wet type, and there are 4 voltage thresholds: 17, 33, 84, and 166 volts. And it applies to all the 10 contact inputs. The contact inputs can be either open or close with a programmable debounce time from 1 to 64 milliseconds to prevent false operating from induced voltage. There are 32 virtual inputs that can be individually programmed to respond to input command via either the relay front panel or through the software. There are 2 steps to use the virtual input. First, we need to enable the virtual input under the setup and set the mode to be latched or self-reset. If the type is set to self-reset, the output pulse will be the same as one protection pulse. In this demo, we're going to use the latched mode. And second step is to go to the control and check the command of virtual input. And we can use the on button to turn on the virtual input 1. In order to monitor the status, we can open the actual values status of the virtual input 1. And for this relay, the virtual input 1 is already on, so we're going to turn it off. Then we're going to turn on again. So now we see the status of the virtual input 1 is off. Now we're going to turn it on again. Now we see this virtual status turned on again. 3 series relays is equipped with 7 relays. Relay 1 and 2 are designed for the breaker trip and close. There are 4 general purpose auxiliary relay 3 to 6 and 1 critical fail relay for the fail-safe relay indication. The relay 1 and 2 can be programmed with a seal-in time to extended reset time for trip or close relay, and they can also be blocked by the selected contact inputs, any logic inputs. Relay 3 to 6 can be set into the self-reset mode or latched mode. In the previous phase IOC demo test, we saw the trip LED was latched even when the fault is removed. Then we need to press the reset button to reset the LED. Let's see why it is working that way in the logic diagram of the output relay. When trip happens, trip LED turns on and will be latched by itself when the reset input is 0. When reset condition is asserted, then LED will turn off. Current demand measurement is available for all 3 relays, and the power demand is available for 350 and 339 relays. Setpoints allow the user to emulate some common electrical utility demand measuring technique for statistical or control purposes. The measurement type can be set to block interval, exponential, and rolling demand. The time interval sets the time period over which the current demand calculation is to be performed. When measurement type is set to exponential, then it changes to thermal 90% response time. Which sets the time required for steady state current to indicate 90% of the actual values and allows user to approximately match the response of the relay to analog instruments. Now let's recap what we learned in this 3SP-103 platform modules. The platform modules, we introduced the common elements for all 3 relays, or at least for 2 of the 3 relays. There are 4 sections: protection, control, inputs, outputs, and monitoring. In the protection part, we introduced phase IOC, TOC, over under voltage, over under frequency, and directional power. In the phase IOC, we give a detailed explanation of the logic diagram of how this pickup works, how this trigger the output relay, event recorder, transient recorder, and also how this can be blocked. And in the phase TOC, we compare the difference between IOC and TOC, how this definite time being replaced by inverse curve, and how we can use the customer curve, flex curve, user curve to define our own special curves. In the over-under voltage, we compare the difference between 2 elements, and same thing, we compare the difference between over-under frequency. And lastly, the directional power, we showed the characteristic angles and how this operation criteria, how this formula works. In the control part, we introduced how to change the setting point groups from group 1 to group 2, how to use the logic element, what's the difference between the version 2.2 and the previous version. In the breaker control, we introduced how to configure the breaker and how to do the local mode breaker close and open. And in the breaker failures, we introduced the setting parameters. In the CT, VT, CT failures and VT fuse fail, we introduced briefly how these settings and logic diagram. In the contact inputs, we introduced the different voltage threshold and also the debounce time settings for the contact input. And in the virtual input, we introduced the 2 steps needed to use command, virtual input command. First, enable virtual input, and then use the command under control to turn on or turn off the virtual input. And in the output relay, we introduced the top two relays designed for close and open, and then the rest are regular relays. And lastly, the monitoring part, we introduced the current demand and the power demand and different types of selections under the demand settings. And that concludes this 3SP-103 platform element module.